Hello students, welcome back to the 7th video of this playlist. So in this video, we will be solving question number 7 from the most recent past paper of Statistics 1, which is the October 2024 S1 paper. So let's get started with the question number 7 of the most recent past paper of S1. So question number 7 says a box contains only red counters and black counters. Okay, there are n red counters and n plus 1 black counters. Okay, fine. Two counters are selected at random, one at a time without replacement. Okay, one at a time without replacement. That means after they have picked one, okay, it can be either red or black. Okay, and then they are not putting it again in that box. Okay, that is what is meant by without replacement. Okay, without replacement from the box. Okay, so that's it. Okay, so part A is asking here to complete the tree diagram for this information. Give your probabilities in terms of and where necessary. Okay, so we need to complete this. What for part A, we need to complete this probability tree diagram. Okay, red or black, right? So n red counters, right? So since there are n red counters, so probability of n red counters would be n over what? N plus 1, which is twice of n plus 1. Okay, and probability of black counters would be n plus 1 over what? Twice of n plus 1. Why is it so? The total number of counters is n plus 1, that is 2n plus 1. Okay, and out of that the number of black counters is what? N plus 1. That's why n plus 1 over 2n plus 1, it is the probability of getting a black counter. Okay, so next, second counter. So in the second counter, there is when they are getting to pick it up for the second time, they're picking out the second counter from that box, and in this when they will be going for the second pickup. Okay, we know that if it is red already, if it is red, right, red has been already once picked up, so one red counter will be decreased, right? That means n minus 1 over, and total number of counters, it's also what? Less by 1, right? Has decreased by 1, so 2n. Make sense? Okay, what about black counters? Black counters are what? Already red has been picked up, so number of black counters is remaining as it is, which is n plus 1. Okay, n plus 1, so that would be n plus 1 over, but the total number of counters is 1 less, that's why twice of n. That's it. Okay, next is for first pick black, second pick red. So already one black counter has been picked up, right? So on the second pick, probability of getting red counter, it's what? Since one black counter has been picked up, so number of red counters, it's remaining as it is, right? So number of red counters it's what? N, right? So n over 1 less 1 counter has been decreased, so that's why 2n. N over 2n, right? So n over 2n is basically what? Half. N over 2n, that would give us what? Half. So that means probability of black counter, that would be what? Also half, because the sum of the probabilities of an event, it is what? 1. So half plus half, it makes up what? 1. That's it. And yeah, that's what part A has asked to do. Okay, fine. Okay, next is part B. In part B, the question is asking to show that the probability that the two counters selected are different colors is n plus 1 over 2n plus 1. Different colors. Red, black, Red, black, black, red. That's it, right? Red, black, black, red. Okay? So, for part B, probability of two counters of different colors. Okay? That would be what? Two counters of different colors. That would be red, black. N over 2n plus 1. N over twice of n plus 1 times what? Times n plus 1 over 2n, right? N plus 1 over twice of n. Okay? This one plus. It is what? Mutually exclusive. This red and black. These are what? Common, intersection. Okay? And red and black, and then black and red. This is basically mutually exclusive. Okay? Because this is different event. Okay? Separate event. So black and red, this is what? N plus 1 over 2n plus 1. N plus 1 over twice of n plus 1 times what? Half, right? If I'm not wrong. Yes, black and red. Okay, so what you will get? N cancels out. So you will get what? N plus 1. So n cancels out. So you will get half of, that is n plus 1 over what? Twice of 2n plus 1. Right? N plus 1 over twice of 2n plus 1, and here you are getting what? The same. N plus 1 over twice of n plus 1. Okay? Now take LCM. In the denominator, we can take LCM as what? Twice of 2n plus 1. So in the numerator, what it would be? It would be n plus 1 plus n plus 1. Okay? You'll get n plus 1 plus n plus 1. So n plus 1 plus n plus 1, isn't it? Okay. So you'll get 2n plus 2 over 2 into 2n plus 1. So from the top and bottom, we can cancel out 2. So you'll get n plus 1 over twice of n plus 1. And that's exactly part B has asked to show, isn't it? N plus 1 over 2n plus 1. Fine. Okay, next is part C. In part C, the question says the probability that the two counters selected are different colors is 25 over 49. So part C is asking to find the total number of counters in the box before any counters were selected. Okay, so the probability given, it is what? 25 over what? 49. So what we can say? We can just equate, isn't it? We can just equate to get the value for n. So n plus 1 over twice of n plus 1. This is equals what? 25 over 49. So just cross multiply. What you will get? 50n plus 25. It is equals to 49n plus 49. Okay. So 50n minus 49n, that would give you n. So 49 minus 25, that is basically 24. If I'm not wrong, 49 minus 25, that is basically 24. Exactly. 20, 49. Yeah, correct. N is 24. So the total number of what counters is what? So total, how many counters? 24 counters exactly. Okay? And that's the answer for part C. Fine. Next is part D. In part D, the question says, given that the two counters selected are different colors. Okay, the two counters that are selected, these are different in colors. Fine. So part D is asking to find the probability that the first counter is black. You must show your working. So from the pattern of the question, you can figure out that this is basically conditional probability, right? The condition is that it should be what? Different in colors, right? It should be different in colors. So we know that the probability of what? Having two different colored counters, it is what? 25/49. It's known to us, right? So out of that, the first counter should be black. Out of that condition, the first counter is black. So this is what? Black and what? Red. Okay? This is black and red. Make sense? So let's find out the conditional probability part D. Look, probability that the first counter is what? Black. Black given what? Two counters of different color. Two counters of different colors. Okay? So probability of two different colors, this is the condition, so that would be in the denominator. That is what? 25/49, isn't it? 25/49, it's given in the question. 25/49, and in the numerator, that would be what? Black and red, right? Out of two different colored counters, this is the what? This is the case where the first counter is what? Black. Okay? So yeah, first counter is black. So this is what? n+1/2n+1. So n+1 is 25. 25 over what? 49. The total, okay. The total number of, we got 24, right? Okay, the value for n, we got 24. Okay, that means I think I have missed out something here. The value for n is 24. Is n the total number of counters? No. Okay. So total number of counters would be n plus 1, right? That is 2n plus 1. So 2n plus 1 is basically what? N equals to 24. So total number of counters, total in part C, please correct it out. Total number of counters, that would be what? That would be n plus 1. This is 2n plus 1, which is basically 2 times 24. This is 48, which is 49. Okay, total number of counters is 49. Okay, so yeah, please correct it out. This is 49, and here, if you consider what? The out of the condition, the probability of black and red, this is what? n+1/2n+1, which is 25/49. So 25/49. 25/49 times, what's that? Half. Okay, 25/49 times what? Half. So this probability is how much? 25/49 times what? Half times what? 49 over what? 25. Okay, 49/25. Okay, so 25 cancels out, 49 cancels out, so this is exactly half. That's it. So the probability that the first counter is black, given that the two counters are of different colors, this is exactly what? Half. And that's what part D of question number 7 has asked for. And that's the end of question number 7. Fine.